Okay, so welcome to NAT for IP version 4. Now, if you're running IP version 6, there's not very much natting you can do in that scenario, as IPv6 is designed to be live addresses regardless of where you are. So we'll be looking at the function of network address translation, how we can have different functions within NAT to give us different outcomes, the pluses and minuses of using it, how to configure static and dynamic NAT, and we'll be looking at PAT, which is what a lot of people don't understand when we talk about NAT is only translating network addresses. It is not translating anything else. So when we actually turn on NAT on home devices, which a lot of people consider that as or what NAT is, they don't understand that we are actually activating both NAT and PAT on those devices with the single click. So what we are doing is actually translating port numbers as well as IP addresses. So this allows multiple applications from different sources to be translated to a single external address. And then lastly, we'll look at NAT64, which is the smaller subset of functions that can work under IPv6. So many moons ago now, we started to run out of IPv4 addressing. And they came up with some patches to extend the life of IPv4 while they developed a successful replacement. Because none of you have heard of IP version 5, have you? So under the original IPv4, we had classes of addresses, and within those classes, we had addresses that were available to everyone. And these addresses were the 10 network from class A, the 172.16/12 from class B, and the 192.168 range from class C. And this came about when we started doing CIDR notations, which was a classless interdomain routing, and NAT. So we came about doing multiple different things to extend the life of the address pools that we had access to at the time. So as I said, we have the ability to translate private addresses to public addresses. So public addresses are live addresses that everybody has access to, and they're the ones that are assigned by owner. The private addresses are the addresses that are on the screen there, the 10, 172.16, 192.168. They can be used in your private networking space without getting any permission from anyone. They're uncontrolled. So NAT allows us to translate those addresses that anybody can use into a public address that is assigned. So we need to set NAT up on the router that faces the outside world, And we basically set it up so that it translates a stub network, which means it only has one way to exit. And we translate the internal private address to the public outside address, which then can connect to the internet and traffic can come back to that point. So what we have is a whole range of inside and outside addresses. One's local, one's global. And what this does is it allows us to do the translation. And as it's a global address, this can be connected to from the outside. So there's 4 types of addresses: inside local, inside global, outside local, and outside global. The inside address is the one that is being translated. The outside address is that of the destination device. So the local address is the address that is on the device that is doing the translation, and the global address is the address that appears to the outside world. I know this can get confusing with all the different terminology. So our inside local is the 192.168.10.10. This is the traffic that is going outside. And we're going to this web server 209.165.2011. So that is the outside local. And you're going, oh, isn't it the outside global? Yes, it is. It's both, just to make life interesting. But what you'll notice is the inside global is translated. Notice the outside global and outside local are not translated at all. So we're only translating the inside local address to an inside global address, which means it's accessible to the outside world. Lots of other text that says what it's not doing with the others. All right. So from PC1, this is the addresses in the header as it arrives in router 2. Before it exits router 2, because these private addresses are not routable, it cannot be routed to an external interface and be pushed out to the internet. So it needs to be translated into the global address that can be used on the outside. So as it leaves router 2, it has both a source global and a destination global. And that way, when a reply comes back, it knows exactly where to come to and what happens as it arrives, because the device knows that this is a translated address that has a table inside of it, and it converts that global address back into the local address and then forwards it out the local interface. So what we want to do is to understand that it's a one-to-one mapping when we're using NAT. Okay, so we're mapping one IP address to one IP address. That is how NAT was designed. But we can automate the process so that we can reuse the available global address pool by putting it as a dynamic NAT, which means we put all of our global addresses together in a pool, and as devices need them, they just use them first in, best dress scenario. So as a device needs a connection to the outside, if there is an available global address, it'll be mapped to that address for as long as the communication exists. After a period of time where there's no more traffic, that translation is removed and the global address is placed back into the pool to be reused by another device. If all addresses in the pool have been used, then no further translation can occur. This is where port address translation comes into play. This allows us to overload the network address translations by mapping each conversation to a distinct addressing by using different port numbers with the same global IP address. We can have more than one conversation occurring in the translation process. So regardless of the local source inside local address, if we still have available port numbers on the global address, we can still use the translation process for that IP address. We just use a different port number. So now we keep track of not only the translation between IP addresses, but also the translation between port numbers for each conversation. Wherever possible, PAT will use the original source port number. This is so that it doesn't translate it where it doesn't have to. Okay. Now, it's not always possible to use the exactly the same port address, because if you have two devices that generate a port number, it can generate the same port number because each conversation is unique. But what happens when it comes up to the address translation engine is that it will continue to translate it, but allocate another address for the port number. So to summarize, NAT only modifies IPv4 addresses. PAT modifies both IPv4 address and port number. And PAT is activated by overloading the NAT process. It's actually the command you use. You've got to tell it to overload, which is turn on PAT. So what do we do when a protocol that needs to be translated, such as ICMP, that doesn't use port numbers, comes in? Well, we actually add an identifier to that so that we can identify the conversation and keep the translations occurring. Here's your packet tracer activity to have a look at that in progress. Now we get into the pluses and minuses. There's many benefits that are associated with NATing. So we get to conserve our registered IP addresses. We get to conserve the larger public pool of addresses. We can maximize the use and flexibility of our connections to the public network. It allows us to have a consistent policy of internal addressing. It allows us to make use of our private address schemes and still connect to the public networks. And in some ways, it hides our internal addresses to the outside world. I hate it when that one's there because we are still connected and it will still translate traffic from one address to another. So yes, we're hidden, but those devices still can be accessed via the public addressing while the translation is valid. So NAT increases the delay in the traffic because it has to go through CPU cycles and repackaging of the headers. End-to-end addressing is lost. Traceability is lost. And if we're using tunnels, such as IPsec, it becomes more complicated because of the tunnel having to be translated. We also have a problem when protocols need to be initiated from outside of our network because our translation doesn't work from the outside in unless we've already established the connection from the inside. So what is static NAT? So this is where we need to translate an IP address to the outside world. Example of this is where we have a server. So we need to map our internal server address to the global address so that traffic can access that server. And to do this, we have to generate the mapping and then tell the interfaces that they're participating in a network address translation. So the first step is the mapping. So the command for that is IPNAT inside source static 192.168. So basically what we're doing is the source of our inside local to our inside global. So the address we're translating internally to the external address. We then have to tell the interfaces that they're participating. So IPNAT, inside or outside. So the inside address is where we are using our local addressing. Our outside is where we're using global addressing. So how do you keep track of what's going on? Well, you can actually view the entries in the table and see what's going on. You can also do a debug and watch traffic come back and forth, which would be interesting, but very resource intensive. So normally the show IP NAT translation command is the one we use. This tells us what translations are occurring. So it'll tell us what the protocol is that's being translated, what the inside global address is, and the inside local address. So you can see what addresses are being translated. Next one is translation statistics. Now this tells us how many times traffic comes to the translation engine and is translated. Now, we've stipulated that a interface is participating in translation. It is then got to match the addressing that is set up in the translation criteria to see whether it gets translated or not. And this is the statistics. So a hit is an address that was successfully translated, and a miss is traffic that is not translated but has arrived on the interface. And there's another packet tracer activity for you to do to see this in progress. Next up is our dynamic scenario, where we're going to create a pool of inside global addresses to be accessed as required. And what we do is give the pool a name. So we have to define the pool. So we go IP NAT pool, give the pool name, and then give the start and finish of the IP addresses in the pool. So lowest to highest, they have to be consecutive, and the corresponding network mask that defines the pool of addresses. You then create an access list to identify the traffic that is to be translated. So this is a simple permit for a network address to be translated to those inside global addresses. Then you set up the translation. So you're going IP NAT inside source. The source is access list 1, and we're using a pool of addresses to translate to, and the pool of addresses we're using is NAT pool 1. You then have to apply them to the interfaces. Remember the NAT inside, outside, such as here. Again, how do we analyze whether this is occurring? We can do this by using the same process of verification commands. And that all these slides are explaining the translation process, which we've gone through, and I really don't feel like you need to be have each bit of text read to you. So we know that the pool of addresses works. We discussed that earlier, so I wasn't going to repeat it again. The IP NAT translations can be seen, and it will list all of the local addresses and the global addresses that have been used. If we type in verbose keyword at the end, this will give us specific information about each translation. So this is where it shows us how long it's been in use, how long it's got to go, where it times out at, what's left on it. So it was created 2 minutes and 11 seconds ago. It's been in use for that entire time, and it's got a valid shelf life of so many seconds, and then it will translate those seconds into hours, minutes and seconds for you for the remaining time. So after 24 hours, that translation is no longer valid and will be deleted from the table. Now, if we've run out of translations and we want to hasten the clearing of the translation table, we can use the clear IP NAT translations and put the wildcard star to clear all of them. Or if you want to clear a specific one, you can give it the clear and put in all the specifics that come with it. Most people just clear the entire translation table, and the next outbound packet will re-establish the translation. So if you look at the statistics again, this time it's because you're using a pool. It'll tell you the start and end address of the pool. It'll tell you the subnet mask that defines the pool, that pool's name, and how many times the addresses have been used, and give a percentage of the pool usage. If you want to see it specifically in the running config file, you can use the options of pipe include NAT, and that will give you the output of the NAT commands. There's another activity for you to do. Now let's move into port address translations. As I said before, this is where we just use the overload command to initiate the simple fact that we want port address translation. So we want to overload the one-to-one mapping, or the pool works with either. So when we create the translation, in this case we're using the example of the access list source, but we're not using the pool. So what we're saying is translate from our source, which is list 1, and use the serial 010 address as our outbound and overload it. So what this will do is translate all matches from the 192.168 series of subnets going to the outside world via the serial interface 010. So it will translate many addresses to a single address and is implied with the serial 010 and the serial 0. Now, here is the same command but being applied to a pool scenario. So we create the pool just like we did in the last example. We apply the access list again, and this time the NAT command is the same as the pool command, except for the last keyword, which is overlay. So that is the only difference between a one-to-one translation and a many-to-one translation. So what generally happens when we have a pool is it'll rotate through all the available IP addresses and then start overloading. So we can go through here and do the step-by-step comparison of the inside source addresses to the destination address. Now remember, when it's coming back in, it's the destination. So this is our inside global, and as it comes in, it gets translated, and our inside local is applied to the headers and is forwarded to the specific device. And that's all. Lots of text to give you the same words. How do we verify? Well, we use the show IP NAT translations just the same as we've done for every other time. It'll just now show us the port numbers attached to the IP addresses. So it's giving us the full socket details for the traffic translation. And if you can't remember what a socket is, that is where we attach the port number to the IP address separated by the colon. And again, statistics will give us the same information as what it did before. And there's a packet tracer activity for us for PAT overloads. Next section is NAT64. So as I said, IPv6 was developed basically making NAT obsolete. So everyone is given a unique local address, okay, that can be used within that, and they basically only are for use within the site. These are not used to provide additional addressing within the IPv6 address space, nor are they there to provide security. So basically there's no need for address translation within IPv6. But we can translate between, oh, I'm getting that message here. We can translate between IPv4 and IPv6. This is known as NAT 64. This was designed to allow the integration of IPv6 with existing IPv4 networks. It's a transition option. So we can configure a router to translate IPv6 packets into IPv4 packets to allow them to have access to those networks. It's not a long-term strategy. It's only meant to be temporary while you transition to IPv6. The issues are not every service provider caters for IPv6, and not every site that you want to access will be available under IPv6. But they will slowly become available. Excuse me. So as we get further into it, you'll do more activities to configure the various scenarios. So there's quite a few packet tracer activities, as with most chapter modules within the course. So in summary, we talked about how we can use a combination of features that were added to the original IPv4 protocol to extend its lifespan. One of these features was the reservation of private addresses for personal use within your organization that are not routable to the public addresses to the rest of the world. And we came about having a patch so that we could translate between these ungoverned addresses to the outside public addresses on a one-to-one basis. So one address for another address. And basically, inside is referred to as what addresses we want to translate. To outside is the public addresses, our destination. Then you have local and global. The local is the inside portion of your local network address space, and the global is the address space that the outside world sees. We looked at the fact you can have a static one-to-one mapping, or you can use a pool of addresses that can be dynamically assigned on a as-needed basis. And although it's outside the scope of this introduction, you can actually adjust the leasing period for that translation to occur. And this translation is on a first come, first served basis. We then added port address translation into the mix, which basically overloads NAT so that we can have many IP addresses translated to a single outside address. This increases delays in transit times, It makes it a lot more complex for troubleshooting and tunneling. We cannot trace traffic as easily because we don't have end-to-end headers being consistent. We can verify the translation services being active using the show IP NAT translations command. We can clear that translation table with the clear IP NAT translation command. And we can also look at how many times an address is translated with the statistics command. IPv6 is not requiring the assistance of this feature because the addressing pool was so much larger, so it doesn't need the ability to translate. What we do have inbuilt in it is a NAT64 function which will translate IPv6 addresses to IPv4 addresses while we transition from one version of the protocol to the next. And that brings us to the end of this presentation. So, do we have any questions? The usual multitude. Okay, moving on.